This is the sixth lesson on the normal distribution, and today we're going to be looking at approximating a binomial distribution. Now, you've studied the binomial distribution and you know that the binomial distribution is used for discrete data when we've got these types of problems where we've got a particular sample size. We want to work out the probability of picking a particular number from that sample size, and we know the probability of success. Well, this topic sort of goes back to the days when you'd have to do a binomial question using tables, and those tables had their limitations. They were limited in the value of n that they went up to, and in the probabilities. You couldn't have every combination of n and p in those tables, so they were limited. So there were cases where maybe the value of n wasn't in any of the tables too big. I think n only goes up to about 50, so if you had 60 for example, you couldn't use the tables. So we'd actually approximate the binomial distribution by using a normal distribution. You can see in the diagram that even though the binomial distribution is for discrete data and there are all those blue bars, the normal distribution fits nicely over the top of it and can be a good approximation if n is large enough. Now, I don't know how many bars are there, but imagine if there were 50 of those little blue bars. I think you'd be a pretty good approximation, or even more. What if there were 100 or 200? There'd be a quite good approximation. So we can use the normal distribution to approximate a binomial distribution. So first of all, we're looking for n to be large. What we mean by that, it needs to be greater than 50, and we also want p from the binomial probability distribution to be close to 0.5. That will give us this nice symmetrical shape. So we can approximate a binomial distribution by a normal distribution if n is large. So what I mean by that is greater than 50 and p is close to 0.5. Okay, so let's say this is our binomial distribution. We've got these values of n and p, and n is large and p is close to 0.5, and we want to approximate it by using a normal distribution. So I use a different letter here. Then the way that we're going to find the mean we're going to do here, we use n times p, and to find the variance here, we're going to do n times p times by 1 minus p. So that also tells you that if you actually want standard deviation, it's going to be the square root of that stuff there. Okay, and that will allow us to make a pretty good approximation using a normal distribution. There's one other thing. There's something called a continuity correction, and that's basically to show that we're appreciating that even though we're doing this approximation, we're basically taking a discrete distribution and approximating it with a continuous distribution. That means when we have a particular value of x, let's say less than a particular value or more than a particular value, we need to do something called a continuity correction. And just for now, I'm just going to say this, that if you have this or this symbol, this will make more sense in a moment, you go out, this will make more sense in a moment, or if you have this or this symbol, you go in, and the amount that you go in or out by is 0.5. This will all make sense in a moment, but this is going to help us do this continuity correction where we may need to add or subtract 0.5 from the value of x. Okay, so let's have a look at this problem here. We've got this coin. I can see straight away that's close to 0.5, 100 trials, that's large because it's greater than 50. Part of the question says write down a binomial model for x. So x is going to be binomially distributed with 100 and 0.53. So there's my n and p straight from the question. Explain why x can be approximated by a normal distribution. Okay, so n is large, in fact it's greater than 50, and p is close to 0.5. It's 0.53, so pretty close to 0.5. Find the values of the mean and standard deviation. So the mean is just going to be n times p. So that's going to be 100 times 0.53. So that would be 53. And standard deviation is going to be the square root of n times p times 1 minus p. So we've already worked out n times p, that's 53. And we times that by 1 minus p, in other words 1 minus 0.53, that's 0.47. We're going to work that out and then find the square root of that, so it's a square root 53, which is n times p, times by 0.47, sorry I missed a 7 off there, times by 0.47, and we get 4.99099. Right, I pretty much could call that 5, couldn't I? Yeah, so if it was a normal distribution, then y would be normally distributed in this question with a mean of 53 and a variance of 5 squared. Okay, well, let's have a look at this one. So we have this binomial question. Already I can see at the top that n is large, it's greater than 50, it's 150, and p is close to 0.5, and it says it's approximated by this. So n times p must be 72, and n times p times by 1 minus p must be 6.12. Use this approximation to find these values. Now this is where we need to do a continuity correction, and remember I said something earlier right at the start about this. If you have this or this, you go out by 0.5, and you have this or this, you go in by 0.5. Okay, basically we're either going to add or subtract 0.5 to the value of x, and the reason we're doing that is, for example, in part A it says the probability that x is less than 70. Now 70 is a discrete number. If I just plug that straight in to the normal distribution, it's going to be wrong, because a number less than or equal to 70, if I turn that discrete number into a continuous number, it could be 69.9, 69.8. Those numbers rounded to the nearest whole number would be less than or equal to 70. Now the way to decide what I need to do with this number is I'm going to draw a number line. I always do these questions on number line. So less than or equal to 70 I'm going to have a line that goes that way with 70 here, so that's what it looked like on a number line. Now this is where I use this little thing here. Now I have one of these symbols at the top, less than or equal to. What that means is, if I want to work out what number that is as a continuity correction, I'm going to go out. So away from my number line, I'm going to go out by 0.5 till I get to the number 69.5. So I've gone out by 0.5, yeah? So I haven't gone the same direction as the arrow, I've gone out. That's what I mean by out. If I was going in by 0.5, I'd go the same direction as the arrow and end up with, oh right, let me correct that. So that shouldn't be 69.5. That should be going out by 0.5, because obviously this is going down below 70, so this should be 70.5, so it's my mistake. 70.5. Yeah, if I was going in by 0.5, which I'm not doing on this question, then I will go back to 69.5. So what we need to do on my calculator, now that I'm turning this into a normal distribution question, is I have a mean here of 72, and I want to work out this area here, and this value isn't 70, it's 70.5. That's this continuity correction thing that I need to do. So on my calculator, load 7, normal CD, lower value, let's choose 0, it's more than 5 standard deviations away from 70.5, upper value 70.5, and I have a standard deviation 6.12 and a mean of 72, and I get 0.403, so it's about 40.31%, or as a decimal 0.4032 rounded. Okay, that's part A. Part B. So here I have that it's greater than 80. So I'm going to draw that as a number line. So 80 is here. Solid circle, that's one. And the other one says less than 90. So I've got, actually I could do it all in one diagram here. So up to 90, open circle, like that. Okay. You could also say, I suppose, if you've got a solid circle, that's what you do. If you've got an open circle, this is what you do. Right, okay, so here at this end, the solid circle, I go out by 0.5, so I'm going to go a little bit more back that way. That would be the number 79.5. And if I go this way, now because of that symbol, it's less than, I need to actually go back. So that would be 89.5. So you always go back or forward by 0.5 depending on what symbol you had. So because of this symbol, you can see I go out from the line by that, and because of this symbol here, I went in, back towards the line. So you either go away from the line or back in towards the line. That's what I mean by going out or in. So let's draw that as a normal distribution. Now that we've done this continuity correction, 72 is in the middle, and we're going from 79.5 up to 89.5, and we want to find this area here, so that's easily done on the calculator. So lower limit 79.5, upper limit 89.5, 6.18 and 72 gives me an area of 0.1081, again to 4 decimal places. on this question here, it's we're going to work out the answer using binomial. We're going to work out the answer using a normal approximation. We're going to work out the percentage error between the two. So let's work it out. The exact answer using binomial would be your 80 0.55, and we want to work out the probability of exactly 50 flowers. And then the days of tables, you wouldn't be able to work out this question because there wouldn't be a table for 80, but we can use our calculators for that. So we're going to go to binomial PD, because we're only working out the value of a single item of exactly 50, not up to 50 or more than 50, exactly 50. And if I work that out, then my X is going to be 50, N is going to be 80, P is going to be 0.55, and I get an answer of 0.0365. So this is the exact answer here. Yeah, that's what it exactly is. Now I'm going to approximate it with a normal distribution. So remember, this is going to be N times P. So 80 times by 0.55, so 44. Okay, so this is this 80 times by 0.55, and then the variance is going to be N times P, 44 times by 1 minus P. Okay, I don't need to square root it, and that's 19.8. Okay, so that's N times P, which is 44, times by 1 minus P, which is 0.45. I'll just check to see if I've done that right. 44 times by 0.45, yeah, 19.8. And we need to do a continuity correction. Okay, now if I do 50 on a number line, it's just going to be that, isn't it? Yeah, so what do? Actually, I need to go out by 0.5 in both directions, because it's a solid circle. There's no line going either way. So actually, we'll go down to 49.5 and up to 50.5. So they're my lower and upper limits. So when you have a single number, you need to go 0.5 both ways, in and out, or out both ways. So if I change that on my calculator, and I'm doing normal CD, lower limit 49.5, upper limit 50.5, 19.8 as, or the square root of 19.8 as the standard deviation, and the mean of 44, and I get this approximate value of 0.03618. Okay, so this is the approximate answer. If I want to work out the percentage error is going to be basically the difference between the exact and the approximation. So in this case, I would do the approximate answer minus the exact divided by the exact answer times by 100. That gives me the percentage error. So I have got rounded numbers here, so yours may be slightly different if you use the exact. So my approximate answer was this 0.03618. My exact answer 0.0365. Okay, probably should have done that the other way around so I don't end up with a negative. Divide that by the exact answer 0.0365. times that by 100, and I get 0.8675. So I've got an error of less than 1%. So 0.8675%. You may get a slightly different answer if you use the exact answers there. So here we're just working out what the that error is. Right, you should be in a position now where you can do exercise 3F on page 55.